Good afternoon. We started with the experimental or the theoretical probability, and we say that when all the possible outcomes are equally likely, we can find the theoretical probability. So the theoretical probability is the number of the outcomes over the number of the all possible outcomes. And today now, we are going to talk about the experimental probability. Experimental, from its name, I made an experiment, I made an activity, and I count and collect the data, and I count how many number or how many things or how many data should I have. So the experimental probability is the number of times the event occurs over the number of times the experiment is done. This is here we call it experimental probability. Let's have an example in order to understand. For the theoretical, as I told you, we have a spinner, we have a dice, we have a deck, and we have a toss a coin. So we said, what are the all possible outcomes? 1, 2, 3, 4, 5, 6 in a die, coin and head in a tossing and a coin. So this is theoretical. This is they are likely to, or they have equally likely to happen. The experimental, no. I make an experiment in order to get the answer. I have, and I repeat the experiment in number. Like I have something, I repeat it more than one time, and then I will count how many times, as an example, get a coin. Let's see this example here now. After receiving compliments, a skateboard manufacturer inspects 1,000 skateboards at random. So they make a 1,000, or they manufacture a 1,000 skateboard. They found that there's no defect in 192 skateboards. So here it's just like ratio, it's just like percent of the probability. Here we have, now all of us know that when you sometimes you think some of them it can work and some of them it cannot work. It has a defect. Defects that it cannot, there's something wrong, it cannot work. So here, after they make the skateboards, they manufacture, the factory, they present, or they fake or manufacture 1,000 things, or 1,000 skateboards. The customer come to the market and buy all of these 1,000 skateboards. After they buy it, they open it, they found it cannot work, there's a defect. They found that there's 9, and some of them didn't have any defect. So they found that 992 of them, there's no defect. So now, what is the probability that the skateboard selected at random has no defects? What you have to say here, the probability will be 992, and they asked me about the probability of the skateboard has no defect. So how many one has no defect? 992 over the whole numbers of trials, which is 1,000. So this is here the probability. How can we find the probability as a percent? I just bring the number, multiply it by 100%. Then here you will find that 99.2% of the skateboards have no defect. So when you come now randomly to choose any of the skateboards, And I told you now that 99% of them have no defect. So you will say, that's mean I have a highly assurance that I can take any of them and have no defect. But if the probability like 10%, like when I have 100, and as an example, I made 100, I am a factory and I manufacture 100 phones, mobile phones. 10 of them only work and 90 of them didn't work. So what is the probability that the selected phones have no defect, can work?
10 over
10 over
the total
100.
number.
Bravo. So 10% of my phones will work. So that's mean if any customer come and take randomly one of the phones, they found that this is a bad factory. 10% only from the whole phones can work. That's mean if I take randomly, for sure I will take a mobile that's not working, because the percentage of the mobiles that's not working is 90%. It's highly percent. So when I take any mobile randomly, it will not work. I will choose a one that's not work. This is here meaning of the experimental probability. As you see, we make an experiment, we make something. We make a mobiles, we manufacture mobiles, we count how many mobiles are not working, because it's an experimental. This is not theoretical. Theoretical, that's mean something that's equally likely. I didn't make a spinner and I'll have a dice and throw it to give you that I will have 1, 2, 3, 4, 5, 6. No, I look at the dice and I tell you that all the possible outcomes from 1 to 6. Is it theoretical? There is no need to throw it to know what are the numbers will be. But here, this is an experimental. For this experimental, if I ask you if you have 1,000, can you tell me how many, what all the outcomes will be? No. You say, okay, it could be have defect or no defect. But how many numbers have no defect? And how many numbers have defect? You don't know. You need to count. That's why the formula for the experimental, the number of times the number of mobiles have no defect over the all number of mobiles. This is here mean the experimental. Is it clear now?
Miss teacher, what's the difference between the theoretical and the experimental?
Now for the theoretical, if I told you now what is the out of the all possible outcome if you're throwing a number cube, what are the possible outcomes will be?
6 over 6.
يعني لا, the whole the outcomes 1, 2, 3, 4, 5, 6. So you can know it. You can know it. Just think by your mind from 1 to 6. But the experimental, if I told you now I have 100 drinks in my bags. Can you guess now? And I have one of them, they are orange and strawberry. Can you tell me how many one are strawberry and how many one are orange?
No.
No, you need to count them. You need to make an experiment, to make an activity in order to count them. To count that I have 5 juice and the other are orange. 5 strawberry and the other are orange. So the experimentally mean I need to count how many one are orange and how many one are strawberry in order to know how many, in order to know the probability of the strawberry juice in my bag. But for the theoretical, no, you cannot. For the theoretical, you can guess. Sure, they will be from 1 to 6, or for the playing deck, they will be from 1 to 52. For the spinner, they will be from 1 to 8. But for the number of juices in my bag, you cannot guess. So this will be now an experimental. Okay?
Okay, miss.
I will not ask you give me or tell me this is theoretical or experimental, but just here to distinguish between them. They have you will deal with them. This you will deal with them as we did in the theoretical or experimental. But just here how to understand. If I come to your class and then I ask you how many girls are as an example born in January, how many girls born in February, how many girls born in June, and so on. This is experimental because I make an activity, I make an experiment, I collect the data in order to find the probability. So I cannot, if I tell you now, Mrs.Dima, can you guess how many girls in the class born in February? I tell them no. I need to count. I need to make an experiment. But if they give me a coin, then they ask me, can you tell me how many coin and how many tail and how many head? I say yes, head and tail. So this is theoretical. Theoretical, it's mean without making an experiment, I can guess the outcome. But experimental, I cannot guess. I need to make an experiment. Okay. Here now, they choose 100 randomly students at the 2000 students high school. Now, most of the scientists or most of the statisticians, when they want to make a study about something, did you remember the survey that I sent it for you for grade 10? To you for grade 10?
Yes, teacher.
This is, we call it a survey. Yes. This survey, that's mean they put a questions, they ask the students in order to know how many students like the online and how many students like the traditional way. How many students have problems in Coursera, how many students didn't have, and so on. This is an experimental probability. Most of them now, if I come now to my school, our school in Nasser International School have approximately 1,000 students, and I want to make a study. Can I ask all of them? No. I will take something, we call it an can say like randomly numbers of students. I can take them, okay, I will take 100 students, 3 from grade 8, 4 from grade 7, 6 from grade 6, and so on. I take 100 girls randomly in order to ask them. When I ask them now, I ask one of the students, what did you prefer to go to make after graduation? After you finish grade 12, what did you want to do? 24 of them tell me that I want to go to the community college. 43, I want to go to a college that has 4 years. 12 of them tell me I want to take a year off before college. 15, go to trade school. And 6, do not plan to go to college. I don't want to go to the college. We ask these students, and as I told you now, they are 100. Now, what is the probability of students that they want community college? How many one are going to the community college?
24.
24. Over?
100.
100.
To the 4-year college?
43 over 100.
Over
43
100.
over 100. For the trade school,
15 over
15.
100.
15 over 100. طيب. For not trade school,
Not trade school.
You plus all the other schools and only
24
not trade.
plus 43 plus
So
12
6
plus
plus
6
12
over
plus 43
another,
plus
yeah, exactly.
1.
Another way,
1 minus the
bravo.
probability.
Thank you. 1 minus 15 over 100, which will be 85 over 100, or as the way you tell me about it, or you can add 6 plus 12 plus 43 plus 24. Fine. Number 32 now. What is the probability that they choose to go to trade school or community college? Now, what's the meaning of or? Plus.
Plus.
So I want to find now the probability that who go to choose to the trade school plus the probability who want to go to the community college. Yeah. The probability who want to go to the trade school, they are 15 over
100.
100. And plus,
Yes.
or it's meaning plus. The probability who want to prefer to go to the community college,
24 over 100.
24 over 100. So they are 39 over 100 prefer to take to go to the trade school or community college.
Teacher, can you wait 1 minute?
Yeah.
So what is
The
this?
last question.
Eh?
The last question, just a minute.
Okay. لا, Farah, what did you say? What did you say?
No, teacher. Here there was like a circle. 100 here with red. So I was asking you what is this? Yes.
Here, because the survey of 100 randomly students.
Okay.
Or you can add them. In order to find the answer, you can add them.
Teacher,
Yes.
here is 15 over 100 plus 24 over what, teacher?
Over 100.
Yes.
In order to find the numbers here, you have to add them. You are welcome. If I don't tell you how many numbers or how many students, you have to add them.
I finished, teacher. Thank you.
Yeah. Now, is it clear?
Teacher, what do you mean by if I don't tell you the number of
Here.
students you have to
I
add?
told you that the result of survey of 100. So you know that the summation is 100. But if I don't tell you, if I give you the table without this, you have to add these numbers. You have to add the number of responses to know how many students did I ask.
Okay.
Okay. For this one here, can you tell me what is the sample space?
Yes.
What all the possible outcomes? Yes, they are green, yellow, blue, red, pink. Yes, I think, yeah, only this. These are all the possible outcomes. Now, then, you know, if I now you play with it, what is the probability that you get green?
2 over.
You have to say 2. How many greens we have? We have 2. 1, 2.
2
Over.
over
How many sectors here we have?
8.
8.
8.
Bravo. So the probability that I choose a green is 2 over 8 or 1 over 4. Right. Now what is the probability of choosing yellow?
3 over 8.
3 over 8.
3 over 8.
Bravo. What is the probability now of choosing blue?
1 over 8.
1 over 8.
Of choosing pink?
1 over
1
8.
over 8.
1 over 8. And if choosing red?
1 over
1
8.
over
1
8.
over 8. So here, I look at the spinner. I can guess what are the possible outcomes. From here, I can write them. Then here, I will write the probability. I didn't ask many students or make a survey in order to collect the colors. This is here theoretical. Now, let's now talk about the experimental. Experimental now. Experimental means I make a survey or I ask my students. Okay, I want now to ask you a question like, here, I want to write the nationality and number of them. Yalla. Now, let's start with the Syria, Jordan, Palestine, Egypt, Sudan, Saudi Arabia, if there's other, yalla, now from the chat. Yalla, tell me now, how many one are from Syria? Raise your hand in the chat, please.
Teacher, can you repeat again?
How many one are from Syria? Huda, Farah, and Basmala, Yara.
Me teacher.
Wait a minute. We are 5 now, sir. 1, 2, 3.
Teacher.
I'm serious.
Yara, Nada.
Me.
Yalla, only,
No.
so only 5? 6?
Teacher Yara.
Yara.
Me. Huda. Sarah. Ranim. Masa.
And also
go.
Sarah.
So how many?
7, something like this.
7. Okay. Now, how many are from Jordan? From Jordan. Basma?
Teacher Jana.
Jana? Who only? Jana مين?
Jana only. And teacher Basma Syria.
Ah, okay. Yeah, she raised her hand. Okay, so Jana. 1. Palestine. يلا سريع.
No
One.
one, miss.
No one.
طيب. Egypt.
2.
2.
2 only
Dana.
Canada.
1.
Dana.
1.
Dana. Ah. Saudi Arabia.
No one. Only Hana.
Only Hannah.
Okay. Fine. So then now, this is here. I come to your school. I come to your class. And then I ask now the girls in the class, from where are you? Now, as you see, 7 plus 1, 8 plus 1 plus 2, 10, 11, 12. So I asked 12 girls in the class. So this is here. I add them in order to find how many girls in the class. Hello, here, does it theoretical? Can I expect how many girls from Syria?
No.
No,
No, teacher.
I need to ask each student. I make a survey in order to collect the data. Then, if I told you now how many girls from Syria, the probability of Syria, you will tell me 7 over 12. From Jordan, 1 over 12.
1 over 12.
And so on. This is here meaning of experimentally. I make an experiment in order to ask what? To know how many girls from Syria. Now then, this is here the difference between experimental and figurative. Got it now?
Yes, miss. Now.
Yes, teacher.
Yes.
Now let's come back. Now here, you ask 500 randomly selected households in your town if they have a dog or no. So then now you come to the city or small town. They asked 500 students or 500, sorry, people. How many of them have a dog? They tell me that 197 have a dog and let's say that sorry, 303 they don't have a dog. Okay, so then now, what is the probability of the people that they have a dog? What you have to do?
1 minus
Have a
probability
dog.
they have dog.
They have a dog. They are 197.
Ah, yes.
How many people in the town?
500.
500.
500.
So if I took randomly the percent, I found that 197 from them have a dog. If your town has 24,800 households, so about how many households are likely to have a dog? Leave this question. Let's come back now to the experiment. I make it with you with grade 8. You tell me that 1/12 of the people from Jordan. If I tell you now, into you ask grade 8 and the probability at grade 8 that 1 from 12 are from Jordan. So if your school contain 1,000 students, can you guess how many students in this school from Jordan?
No.
No, see here. Why I make this experiment? I told you that some of the people, they didn't ask only the 1,000 students, or as an example, 10,000 students. I cannot ask all of them. I take a random sample. This random sample was grade 8. I asked 12 girls in the grade 8, from where are you? One of them were from Jordan. So the probability of the girls from Jordan, they are 1/12. Now, if I ask you now, how many students? How many students? So I'm asking you now about what? Number of people, about a number. Which percent number? How many students now in your school from Jordan? What you have to do? You have to say them. In my school, we have 1,000 students. And the probability that I know it from grade 8, that 1/12 from the students are from Jordan. So when I multiply 1/12 times 1,000, I get 83.3, and approximately 84. So I can say that 84 students in our school from Jordan. That's why we make the survey. We make the survey to analyze the data and also to guess the number of the students or the number of the people in the whole or in a big country. So when I make my survey in grade 8 only, I can guess from this probability, I can guess the number of the students from Jordan in our school. Here now we have the sum. Here they asked, we have 2,480 students, 80 people, sorry, in the country, as an example, or in the household. And I want to see now how many of them have dog. I cannot ask all of them. I come to the small town. I say, like, this small town has only 500. Wallahi, 500. I can ask them. For this 500 now, when I asked them, I found that 197 only have a dog. So I can say, like, that's mean the probability of the people have a dog. They are 197 over 500. Now, from this number here, from this percent here I can know how many households from 2,480 they have a dog. How can I know? I just multiply the probability of have a dog in the small sample space, multiply by the whole numbers of the whole number of people in order to guess how many people have a dog. After we multiply, we find that the answer is 0.2. Hella, be careful. How many households? How many? I'm asking you about number, not percent. So I want a number, not fraction. طيب. Now, how many people? Can I say that we have 9 people and half? No, they must be integer. So I will round this number to be like 9,771 people. And this will be now by logic, will be true. They cannot be 9,771.2 because we are a people. We cannot say, wallahi, we have 9.5 girls in the class. Is it clear?
Yes, teacher.
Yes, teacher.
Right. Now,
And teacher, this total will be correct or like guess?
لا, this will be correct. I make a survey. You mean إنه لا هلا approximately they will be correct. هلا if you actually go and ask all of them, they will not be exactly 9,771. They will be nearest this number.
Okay, miss.
Okay. Now this question here, number 33, there's no only 1 minute. I will solve the question and send it on WhatsApp. They have the same idea.
Okay. Okay.
Thank you so much.